Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you about deep learning with the TensorFlow 2.0. So this is the second lesson on deep learning with the TensorFlow 2.0. If you haven't watched my first lesson, you can go ahead at my channel KGP Talkie, and there you can watch the first lesson, a TensorFlow 2.0 and the Keras for beginner with the coding and the working example. And in this lesson, I'm going to show you how you can build your first artificial neural network with the TensorFlow 2.0 and its high-level API, Keras. If you don't have installed TensorFlow 2.0 in your computer, you can go ahead and open your Anaconda or the command prompt in administrator mode, and then run pip install TensorFlow 2.0.0. RC0 represents that it is a beta version. You might get some error while installing or working with the beta versions of the TensorFlow, but hopefully the TensorFlow should also release a stable version of a TensorFlow 2.0. It depends at the time when you are watching this video. And if you have a GPU in your computer, you can go ahead and install a TensorFlow GPU as well. Okay, so you only need to install only one version of a TensorFlow. So in the first section, I'll talk about the theory, where I'll first tell you what is artificial neural network. Then I'll tell you about what is activation function and how we can use these activation function. Then I'll talk about the backpropagation, and then we will talk about steps for building your artificial neural network. Then after that, we will start with the example. So I'll first show you how you can import necessary packages in your Jupyter notebook. Then we will start working on a data set, a customer churn modeling, in which a bank has given a frictional data, and based on these features, we need to identify that whether the customer is going to stay with the bank or the customer is going to close an account and get away with the bank. Then we will be reading it with the input and the output vectors, and then finally we will be encoding these string values into categorical values and numerical categorical values, and then finally we will be doing a feature standardization so that we can bring down all the features into a same scale. Then after that, I'll show you how we can build our first artificial neural network. Then I'll show you how you can train your model using model.fit. And then after that, I'll show you how you can calculate the accuracy and you can evaluate your model. And if needed, you can change input parameters, optimizations, or hidden layers, etc. to optimize your model. Okay, so without wasting your time, let's go ahead and start a brand new lesson on artificial neural network. The first thing comes in our mind that what is a neural network or artificial neural network? Artificial neural network is a supervised learning system built of a large number of simple elements, which is called a neurons or a perceptron. If we talk about in the biological term, it is known as a neuron, and in technical term, it is known as a perceptron. Each neuron can make a simple decision, and it can feed those decisions to other neurons organized in interconnected layers, as it is built in our mind, as you can see here in this figure. The basic functioning of our artificial neural network, which is shown here, this is kind of, we can say, a natural neural network, and that is built with the biological function or a biological neural network. And here artificial neural network, which is a human made. Human brain learns as a result of getting trained by a sample data initially. For example, we learn to call a fruit apple after initially getting trained to see apple as object in real life or its image, and simply for orange or any other fruits, animal, etc. And simply we do the same things for artificial neural network. We initially train it, we make it learn, and then after that it starts the predicting. The most simple neural network is a perceptron, which you can see these things, and these are actually the node, and it's the simplest form is consists of a single neurons. Okay, so these are the neuron, much like a biological neurons, which have a dendrites, axon, and a simple artificial neural networks. So these artificial neural networks can be a mini type, and those could be a shallow or a deep neural network. So here is an example of a shallow and the deep neural network. A shallow the neural network is having just single hidden layer, and it has an input layer and an output layer. Okay, but in deep neural network it has a multiple hidden layers, and along with the input layers and the output layers. Okay, and these layers are interconnected with, you see here, kind of the axon, and once input comes here, like here you see, and these are the units are the number of nodes, and it is getting multiplied with the weight, and then finally there is a summation function with some particular activation function. Okay, so in the next section we will learn what is these activation function. That's mean what is happening here with these the input nodes. All those nodes are getting multiplied with particular weights, and then finally there is some activation function which is producing a final output. And now these outputs could be the many outputs, like here it is just a single output, but here this is multiple outputs in case of a multi-class problem. Okay, so what is the activation function? Okay, the activation function, if we let's understand, if we don't use the activation function, then what happens? If we don't apply activation function, then the output signal would simply be a simple linear function. That's mean what can happen here, you see, if the activation function we doesn't apply, then this would be just a multiplication with these weights and plus summation and then the output. And if you remember in my previous lessons in a linear regression, so this will be a kind of a linear regression where each features are getting multiplied by with the linear regression coefficients. That's mean we need something which can learn a complex pattern in a deep neural network. Okay, so there are many types of activation function, like a sigmoid activation function, tan H activation function, a ReLU activation function, and a leaky ReLU is kind of the advanced activation function. So these are actually the most widely used activation function, and the softmax activation function is also there, which can write here the softmax as well. Okay, so these are the just kind of the activation function which we will be using throughout our this lesson. Now let's go ahead and understand how these weights are getting modified. For example, let's say the ones at the first epoch our neural network get trained, and it at the final output it calculate the error, and if there is any error, then it again feed that with some loss function, and it tells these weights to update according to the error, so that the error should be the minimum, and those measures are getting fed by a loss function, and the process is known as a back propagation. So what happens in a back propagation? Let's say the first time in a forward propagation, weights get the updated, and then in hidden layer the nodes got updated and the final output calculated. Now it compares the final output with the true value, and if there is error or a large error, and then with the loss function it calculates those errors, and then it feed back to these weights with the back propagation techniques, that let's update these weights and minimize this error, so that these errors between the true value and the predicted value should be a minimum. This is how a back propagation work. Now let's go ahead and see how you can build your artificial neural network with the TensorFlow 2.0. This is very simple process. You can use you need to do first data pre-processing. That means read the data and prepare a data for model input, and then add an input layer. And once you had added the input layer like here, and then you need to add a hidden layers. Now it depends on the data and your model how many hidden layers you want to add, and at the same time initialize a random weights while adding a hidden layer. And then you need to select the optimizer, loss function, and a performance matrix. A performance matrix means how you want to measure the performance of your model, like accuracy, F1 score, or sensitivity or specificity. And once you select all these parameters, then you need to compile your model. So before training your model, you need to compile your model. So once it is compiled, then call model.fit to train your model. Once it is trained, then evaluate your model based on the past parameter in a performance matrix. And once you get the evaluation of your model, now you can see and you can optimize the parameter like optimizer, loss functions, and performance metrics. Otherwise, you can also optimize your model like adding the hidden layers or removing hidden layers if needed based on your requirements or accuracy requirements. Okay, now let's go ahead and start building the model into a TensorFlow 2.0. And if you don't have a TensorFlow 2.0 installed in your computer, you can go ahead, you can write pip install TensorFlow 2.0.0 RC0. Otherwise, it depends on the, at the time you are watching this video, what version the TensorFlow is out in the market. And otherwise, in the previous lesson, I have also covered in very details how you can install the TensorFlow 2.0 with the deep learning with the TensorFlow 2.0 tutorial, where I had shown you a basic coding example, the fashion amnesty data classification, that you can watch and understand how you can install. Otherwise, you can just go ahead and write there pip install TensorFlow 2.0, it will install, okay, necessary libraries. Perfect. Now let's go ahead and first call a TensorFlow. That's mean let's go ahead and import a TensorFlow and Keras from a TensorFlow in our Jupyter notebook to work with the TensorFlow. So here we have import the TensorFlow IHTF, and then import TensorFlow now we need to actually import Keras from TensorFlow. So from TensorFlow import Keras, and similarly from TensorFlow dot Keras import sequential. Now if you know here, or if you have seen the Keras videos previously, there we had to import the Keras separate. But here with the TensorFlow 2.0, the Keras is coming with the core of the TensorFlow, and it is very tightly coupled with the TensorFlow so that it can optimize the training time. So we have here imported a sequential model, and now let's go ahead and import here flatten and the dense layer from Keras layers. Okay, so here we have a flatten layer, and then we have here a dense layer. Okay, so after that, now let's go ahead and see the version of the TensorFlow which we have currently installed in our computer, that we can get with this one. Now you see currently I have a TensorFlow 2.0 installed in my computer. So this version is available for a non-GPU computers, and this is available for a GPU computers if you want to use a GPU to train our model. Since these are the very simple artificial neural network, we actually don't need a GPU to train our algorithms. Now let's go ahead and import the helping packages while the pre-processing of our data. So let's go ahead and import numpy as np, import pandas as pd, and import here. I don't think we need a matplotlib, so let's don't import the matplotlib. And then here we need sklearn dot model selection, import train test split that we will be needing. I also, yes, the train test split, so that we can split our data into the two part, training and testing data. Now let's go ahead and read the data which we want to work on this lesson, in this lesson. So the file I have already I already have that file here, a customer churn modeling. That's when there is a fictional bank which has provided a data, and based on those data we need to identify that whether a customer is gonna leave the bank or not. Okay, so we are going to implement it into a deep neural network or artificial neural network. So let's go ahead and read the data in a dataset objects with the dataset dot read CSV. So here we have read CSV, and inside the read CSV we need to pass here the dataset that is a customer churn modeling.csv. And now let's go ahead and see ahead of this dataset. That's mean the few lines, initial lines of a dataset. It says that here you see almost 13 or 14 columns are there, and the last column says that if customer is gonna stay with bank or not. That's mean exited 1, that's mean the customer is gonna leave the bank, and the 0 means customer is gonna stay with the bank. So this is kind of a fictional data where the bank want to understand whether their customer is gonna stay with the bank or not. Okay, now you see here the one thing, the row number. Okay, so these are just a simple row number that doesn't actually give much information to predict the final output, and the customer ID also doesn't give. That's mean the customer ID should not be correlated with the persons whether they're going to stay with the bank or not, and the surname could be correlated since the surname could be related, but in this lesson we are going to drop these 3 rows: row number, customer ID, and the surname. And apart from that, the other features, if you see, these are highly correlated with the output, like the credit score. Geography could be also very useful, and the gender also could be, the age, the tenure means the person, how long person have been with the bank, and the balance in the person's bank account, and the number of products means how many products of the customer currently the customer having with the bank, like saving accounts, credit cards, debit cards, FD of the fixed deposits, the loan, etc. And whether the person is having a credit card or not, whether the person is active member with the bank or not. That's mean the person is currently active with the credit cards or bank products. And then the estimated salary which is being credited to the bank account are the person's the estimated salary. So based on these parameters we can identify that whether the person is going to stay with the bank or not. So let's go ahead and read the necessary data into X vector, X feature vector, that we can read with the data set dot drop, and the labels which we are going to drop here. The first one is the customer ID. Okay, so we can just copy it and let's go ahead and paste it here. And then apart from customer ID we have here a surname, and apart from the surname we have then of course the first one we have forward, that is a row number actually. Okay, so these are situated into axis 1 in the column. That's mean we need to also pass here axis 1. Now let's go ahead and read the y in, that's mean the final vector. And one more thing, this is a row number, and since this is input vector we need to also drop this final label, and we need to read this final label into y vector. So let's go ahead and copy this. Once we copy, and we are gonna paste it here and here as well. So now we have our x. It says that the data is yes, so here this should be actually the data set, not a data. Okay, we have got here our input feature vector and the output labels in x and the y. Let's go ahead and visualize x, the few lines of the x. Now you see here, and of course here we have y as well, which shows that whether customer is gonna stay with the bank or not. Now the one more thing you might notice here is that artificial neural network works on a numerical data, not on a, the string data. So here you see the geography and the genders. These are the string data. That means we need to map these data. We need to map these data into a numerical data. So in my previous lessons, I have shown how you can use a dictionary and a map function to map these string values into a numerical values. But in this lesson, I'm gonna show you how you can use label encoder and one hot encoder to convert these string values into a numerical values. So let's go ahead and first import label encoder. Okay, so we are gonna import label encoder from sklearn dot preprocessing and import label encoder. So label encoder, what it does, let's say you have male and the female label, then it will encode it into a numerical values. So let's go ahead and first create a label encoder for the geography and then for a gender. Okay, so here we have let's say a label 1, and for a label 1 we are gonna create here a label encoder that is for geography, and let's go ahead and do that in the same folder. And then finally we have here our x vector, and inside the x we are going to work on geography folder, a geography feature. And inside the geography features, what we can do, we can just write here a label 1 dot fit underscore transform. Okay, underscore transform, and there we need to pass for which we want to transform. So we want to transform it for a geography. Okay, so with this it is transformed, and now let's go ahead and see the head of this data. So with the head, now you see it is transformed with the 0, 2, 0, 0 and the 2. The 0 means the France and the 2 means Spain. So we have another one as well in a geography, which we can see if we, let's go ahead and see the top 10. Yes, so in the top 10, it has changed here, otherwise we could have seen that here. We can see that here as well with these top 10. So with the top 10 we have geography Germany as well. Okay, perfect. Okay, now let's go ahead and make it as a previous. Perfect. So here we have now the 0, 2 and the 1 as well, and now we need to convert this gender as well. So for a gender, what we can do, we can apply a same thing as we did earlier. So for that, let's go ahead and do a label is equal to label encoder, and then x, and then here we have a gender is equal to label, then dot fit underscore transform. So inside that we need to pass for which column we want to do a transformation. So we want to do for a gender. Now let's go ahead and see the head of this gender. Now you see the gender has been converted. The mostly female has been converted with the 0 and the male has been converted with the 1. Okay, so now you see. So now we have converted our string values into a numerical values. Now the question comes here, is it right to convert? That means in geography we have 0, 1, 2. Okay, so these are numerical value. So the 1 is greater than 0 and the 2 is greater than 1 and the 0. But that doesn't mean that the two have a more importance than 1 and the 0. Since these are the string values like a male and the female importance are equal, and similarly the geography importance should be the equal. That's mean we should not treat these data like numerical values, but we should treat these data like a categorical value. So for a categorical values, we always need to convert these categorical values into a one hot encoding. Okay, so for one hot encoding, what we need to do, we need to do Since this is already a pandas data frame, we can call just get dummies, and then we can see that x is equal to the pd dot get underscore dummies, and then here we have x, and then we have a drop first is equal to the true, and then the columns which we are gonna use for get dummies, that we are gonna use for the geography. Okay, so that's the geography. Sorry. Perfect. Oops. Now you see here, the geography has been converted into a geography 1, geography 2, but you see here the geography 3 is not there. Because if we make a geography 3 as well, then it will become a redundant, and it will fall in kind of, you know, there that, okay, so I mean that doesn't include much information in the prediction. And we could have done for a gender as well, but since this have just a binary value 0 and 1, that means we don't need to do anything for a gender. But other data are actually a numerical data which have a continuous value, and but the genders and the geography was the categorical value. So that is the difference between the categorical and the continuous value. In categorical values, we always need to convert these with one hot encoding. So you can convert with the get dummies as well, otherwise you can call one hot encoding in sklearn. And now let's go ahead and do the feature standardization. Now you know why we do the feature standardization. Okay, let me tell you why we do a feature standardization. Feature standardization, okay. Standardization. Now you see here what we are actually having. The scales of these features are pretty much different. Okay, the scales are varying too much, and in a machine learning, these scale differences or variance differences between the columns is not recommended. So what we need to do, we need to bring down all these the features scaling in a same scale actually. Okay, and we can do that with the feature standardization by calling standard scaler from sklearn preprocessing package. So that we can call with sklearn dot preprocessing import standard scaler, and then here we have scaler is equal to standard scaler, and then here we have x underscore train is equal to scaler dot fit transform. Okay, so there we have x underscore train, and then here we have x underscore test is equal to scaler dot transform. Okay, so with this we have x underscore test. Now it says that x underscore train is not initialized. This is because I just forget to call the train and the test split. Okay, so here we need to call x train and x underscore test, and then we also need to call y underscore train and y underscore test is equal to train test split. And then after that we need to pass here xy data, and then I'm gonna pass here a test size, that's mean for testing 0.2, that's mean 80% for training and 20% for the testing, and a random state which I'm gonna call here, the put is the 0 and the stratify along with the y, that's mean divide the y data the symmetrically between 80 and the 20%. Okay, so now here we have bring down our data x train, if you see here, okay, in between somewhere -3 to +3. So if we do the standardization, with the standardization, the data comes in between somewhere -2, -3 to +2 or 3. So now all the columns has came down into same scale. Now we are ready. Now we are ready to to build our artificial neural network with using a TensorFlow 2.0. Now let's go ahead and build the ANN. So for building ANN, as usual, we do here model is equal to the sequential. Okay, so that's the sequential model, and then here we have a model dot add. Inside this, what we are going to add here, the first input layer that will be added with the dense layer, and the number of input nodes which I'm gonna add there. You can get with the shift and the double tap a detailed documentation of this. So we need to pass a unit, and inside the unit I'm gonna just pass here x, the shape of 1, that's mean the total number of features, which is 11 actually, and then I'm gonna pass here activation function. So the activation function in this, we are gonna pass a ReLU. So generally what we do in input, we pass a ReLU activation function, and in output we pass sigmoid or a softmax. And now let's go ahead and pass here input dimension. So how much input dimension is there? Input dim is, we are having x shape, and this is input dim. If you don't know what is the value of x shape, you can just write here x shape, the one which is 11 actually. Okay, perfect. Now let's go ahead and add the another the hidden layer here. So there I'm going to just add a single hidden layer, and in this hidden layer I'm going to add a hidden layer with 128 the units, and then the activation function for a hidden layer I'm going to use a ReLU. And one thing you might notice here that I'm not going to add input dimension since this is not an input layer. Now let's go ahead and add the final output layer. So in output layer there is just the one values, that's mean the two values, which can be actually we can get with either 1 or a 0. So there I'm gonna call there, I'm gonna add just a single value, a dense layer, and with the dense layer I'm gonna add just a single node. If node gives the output 1, that's mean the customer is gonna exit the bank, and if output node gives the 0, that's mean the customer is going to stay with the bank. And in the finally we are going to put here activation function is sigmoid. Okay, so here we have a sigmoid activation function. So this is how we have built our model. Now let's go ahead and compile our model. Do you remember the steps for learning these things? So we have built, now we need to compile, then finally we can train, and then we can evaluate our model, and if needed we can make some changes in our model as well. Okay, so what we are going to do here, the first we are going to compile our model, so that we can compile by passing a parameter, optimizer, loss, and the metrics. So there the optimizer which I'm gonna use, Adam optimizer. Adam optimizer is kind of the stochastic the gradient optimizer. So we are not gonna use here a batch gradient descent algorithm. Otherwise in batch descent gradient descent algorithm takes a lot of the time to train the model. And optimizer we are gonna use here Adam, and for this loss function I'm gonna use here a binary cross entropy, since this is just the binary classification. Otherwise we cannot use a binary cross entropy here. So here we can press a shift and the double tap to get the detailed documentation, and inside this if you see there a loss. Okay, we should get somewhere a loss. Okay, yes, here. So inside the loss, so it has actually the detailed documentation about this, how you can work with this. Okay, and now let's go ahead and see the metrics on which basis this will be model will be evaluated. So the metrics takes a list which you can get with the shift and the double tap. The metrics takes a list of the list of the metrics, and you can pass the accuracy and MAC and other things as well, but here we are just gonna pass accuracy. So this is how we can compile our model. The model has been compiled. Now let's go ahead and start fitting a model, which we can use with the model.fit. A model.fit will start fitting a model, and then here we have x underscore train and then y underscore train. Since x train is a numpy array, y train should be also a numpy array. There we can convert that with 2 underscore numpy. It will convert this y train, which was earlier pandas series, it will be converted into a numpy array, and then we need to pass here a batch size. Okay, so the batch size is 10. That's when it says that in stochastic gradients how many the rows, how many the data points it is going to take to calculate the new weights. If batch size is 1, that's mean for every input it will update the weights. That will be kind of too much random. And if batch size is equal to the size of your total data, then the stochastic gradient will become kind of batch gradient. So here batch size is 10, and then the epochs which I'm gonna pass here is 10, and the verbose, you see here the verbose is equal to 1. That's mean it will give us the, you know, how our model is getting trained, and it will, you know, it will be giving us the progress bar of training as well. So let's go ahead and hit the shift and the enter. Now it will start here training our model. You might get some kind of you know, the warning, since we are using a TensorFlow 2.0 beta version, so you might get kind of, you know, these kind of the warnings, since this is not a stable version. So with this, you see the model has trained very quickly, and we are getting accuracy of 86.1% on a training data set. Do remember, this is not accuracy for a testing. This is accuracy for a training data set, and the number of epochs which we have used here is just a 10. Although you can convert this number of epoch to the 20, and then again you can see how the accuracy is changing. But the one thing you notice here, the accuracy has started from the 86 because the model you know, again is getting retrained on the trained model. So what we can do, we need to run it from the initial, so that the model should be, you know, the empty before we go for 20 epochs. Now once again it has started from 80.62, and if we increase the epochs the 20 from the 10, now you see the accuracy is getting stuck with somewhere 86. That's mean the loss is not decreasing. So if your loss doesn't decrease, that means it shows that your model is getting overfit. That's mean our model should not overfit. So let's make it epoch is equal to the 10, but actually we need to make it from there. So let's stop it and run it from here. So for 10, okay, so the model should not overfit. Once model is trained, now we need to predict our classes. So how we can predict the classes? We can simply call here ypred. Ypred is equal to model dot predict classes, and there we need to pass here x underscore test. So with this, now we have y underscore pred, and if we print it with the actual value, now you see what we can do, we can see here the y pred, and then we can see here y underscore test. Now you see the very first value is wrongly predicted in predicted values, and the second two values are predicted correctly. And if you see the last three values, is kind of also correctly predicted. So now we need to calculate what is the accuracy of the prediction. How you can do? If you remember, in the previous lessons we have used the evaluate model. Okay, so there with the model and then evaluate the model, and there you can pass there the x and the y other things, there it can evaluate the model. That's mean what we can do, we can pass here x underscore test and then y underscore test. That's mean on the test data set, it will evaluate, but we need to convert it into a NumPy. Since we had also seen in our previous videos that it was throwing some kind of the weird output, but if you go at the end you will get the accuracy on testing data set. So the accuracy is here 85.95%. So this is how we can calculate the accuracy based on the model that evaluate in the TensorFlow 2.0. But we have our another method as well to get the accuracy and the confusion metrics by calling sklearn.metrics. So let's go ahead, import the confusion metrics and accuracy score from sklearn.metrics. That we can do with sklearn.metrics. Import the confusion metrics as well as the accuracy score. So here you see we can print the confusion matrix there, y underscore test, that is the true value, and then here we have y underscore pred. So this is a confusion matrix. So this is the 1532 times it has correctly predicted, okay, if the customer is gonna exit or not, and 187 times it has predicted correctly if customer is gonna they stay or not. Let's go ahead actually see the accuracy, okay, at the accuracy score. So in accuracy score, what is happening here, y underscore a test, and then here we have y underscore pred, okay. So with this you see the accuracy of the prediction accuracy which we are getting is 85.95%, and similarly we had got that with the model.evaluate as well. So this is all in this lesson. In this lesson we have learned how let me delete first. So in this lesson we have learned how we can use TensorFlow 2.0 high level Keras API to train our artificial neural network model, and this was also an introductory lesson how you can build your first artificial neural network using a TensorFlow 2.0. okay, so this is all about in this lesson. Please don't forget to subscribe this channel and like this video. Bye bye, have a nice day.